Test Electricity Review Part 2. In this video, I'm going to explain how to solve problems number 5, number 21, 23, and number 24. So let me start with problem number 5. This problem asks to fill the table with voltage, current, and resistance values for the circuit at the right. Here we have two resistors, R2 and R3, in parallel, and the combination of both in series with resistor R1. So this table provides the resistance for R1, R2, and R3, and the total voltage, which is 6 volts. To calculate the total resistance of the circuit, first I need to calculate the equivalent resistor for the parallel between R2 and R3, showing here. So that's my first step. So the sum of the inverse of those resistors is 12 ohms. So now, to find the equivalent resistance of this circuit, we need to add the resistor 1, which is 10 ohms. So 10 ohms plus the equivalent between these two in parallel is 22 ohms. Now, let's complete the total resistance at the table with 22 ohms. Next, we need to calculate the total current. So the total current is the total voltage, which is 6, divided by the total resistance, which is 22. So our total current is 0.27 amps. The total current is the same, flowing through resistor R1. So we can fill our table with this information. Now, because we have the information for current and resistance for the first resistor, we can calculate the voltage. So voltage is current times resistance. The result is 2.7 volts. Now the voltage on R2 and R3 is the same, which means that the total voltage is equal to the voltage drop on R1 plus the voltage drop on the parallel between R2 and R3. So the total voltage is 6. The voltage drop on R1 is 2.7, and we don't know how much is the voltage drop on the parallel between R2 and R3, but we can calculate using this equation. So 6 minus 2.7 is 3.3 volts. So we can complete this table for both R2 and R3. Voltage is 3.3 volts. The last step is to calculate the current flowing through R2 and R3 using Ohm's law for current. So we have the voltage and we have the resistance. So we can calculate the current after R2, which is 0.165 amps, and the R3 is 0.11 amps. Problem number 21. A 110 volts household circuit that contains a 1800 watts microwave, a 1000 watts toaster, and 800 watts coffee maker is connected to a 20 amps fuse. Determine the current, and the question is, will the fuse melt if the microwave and the coffee maker are both on? So here we have a table that translates all the information that was given by the problem. The voltage and the power for each appliance. We are using the formula for power, voltage times current, to find the current on each appliance. So for the microwave, we have the power is 1800 watts divided by the voltage, which is 110 volts. So the result is 7.27 amps. So we repeat the same process for the toaster and for the coffee maker. So now let's translate this circuit to a schematic circuit, which means that we are using symbols. So for each appliance, we are replacing by the resistance. So here is the power source, and this is the fuse. So since the current on the microwave, which is the first one, is 7.27, and the current on the over the coffee maker is 16.4. If we add both, we are going to have a total current between them of 23.7 amps. Notice that didn't say nothing about the toaster. So the impression is that in this circuit, just the microwave and the coffee maker, they are working simultaneously, but not the toaster. And the question is, when this happens, will the fuse be enough to support the current flowing through it? Now, since the fuse, the maximum current the fuse can support is 20 amps. So the fuse will melt and the entire circuit will be off. Problem number 23. Resistors R1, R2, and R3 have resistances of 15, 9, and 8 ohms respectively. R1 and R2 are connected in series, and their combination is in parallel with R3 to form a load across a 6 volts battery, just like that. So this is the A, that's the circuit diagram. So the current, this current is the total current produced by the 6 volts battery. And when the current hit this knot, it's going to split. Part of the current is going to flow through this branch that is the series between R1 and R2, and part of this total current will flow through R3. Okay, so now we are going to fill this table and then answer these questions. So a couple things that we have. We have the total voltage, which is 6 volts. Now, because I have the values of all resistance, so I can calculate the total resistance. My total resistance is these. I have two things in parallel, but these two are in series. So I have to add R1 plus R2, and the result is parallel with R3. So that will be my formula. So it will be the inverse of the sum of these resistors. So here I have to add those two first before invert. So then I have a 24 and here is 8. So now I do on my calculator use the inverse key. So 24 inverse plus 8 inverse is equal inverse one more time, and then I have my total resistance, which is 6 ohms. So I fill in this table. Now I can calculate my total current. So the total current is the total voltage divided by the total resistance. 6 volts divided by 6 ohms, which is 1 amp. Now that I have 1 amp, I can look and see what I can derive from here. So number one, the voltage on my resistor 3 is the same of the battery, which is 6 volts. Now with this information, I can calculate the current flowing through resistor 3. So my current is voltage divided by resistance. 6 divided by 8, 0.75. Okay, so if I have 0.75 flowing here and my 1 is here, so I can conclude that the current that is flowing in this branch is 0.25. So 0.25 is a current that is flowing through R1 and R2. Now that I have information about current and resistance, I can calculate the voltage drop for each of those two resistors they are in series. For my R2 is current times resistance is 2.25, and here current times resistance is 3.75. The last problem. A 15 resistor is connecting series with a 120 volts generator, and two 10 ohms resistors are connecting parallel to each other. Draw the circuit diagram. So that should be something like this. So I have a resistor of 15 ohms in series with a generator, and in parallel with those two resistors. They are equal. Each one is 10 ohms resistors. What is the total resistance of the load? So the total resistance will be this resistor plus the parallel between R2 and R3. So the total resistance will be 15 plus 10 parallel with 10, which is 5. So my total resistance is 20. And my total current is the total voltage, which is 120 divided by 20, which is 6. So now I can fill my table. So the total resistance is 20, the total voltage is 120, and the total current is voltage divided by resistance, which is 6. Now, since the same current, total current, is the one that is flowing through R1, so I repeat the value of the current right here, and I can calculate the voltage across R1, which is the product of the current times the resistance, which is 90. So since this one over this is 90, so the difference between 120 and 90 will be 30. So 30 volts is the voltage drop between this branch right here. So 30 is the voltage over R2 and 30 is the voltage over R3. Now that I have voltage and I have resistance, I can calculate the current that is flowing through each resistor, which is voltage divided by resistance. Voltage divided by resistance. Very simple problem.